Welcome pre-calculus students to class today on Tuesday the 19th. Here are your announcements. We will have a test on Monday. If you're not going to make it Monday, please let me know by Sunday, no later than Sunday. And this will be test number 5, 6, I think test number 7, okay, of the semester. Your integrity sheets are due when you walk in the door. You will not be able to go home and watch any more videos and do any more homework, at least not and get credit for it. You can go do more, but you will not get credit for it. Your quizzes were due yesterday. Some of you have not contacted me. I am, unfortunately, in a very loving way yet firm way, taking 5 points off per day. And so those that have not contacted me at all, I might just go ahead and take the points off, to be honest, just because you've not contacted me. I mean, it's your job to not contact me on Wednesday or Tuesday, whatever, and say, hey, it was done Monday. You're to contact me Monday when you're done and tell me. And so please take care of this. Our last day of class will be this Monday. So this Monday you will come to my house and you will take a test. Then you will have no videos for Tuesday, Wednesday, Thursday, or Friday. So the next video you will watch will be a week after your test on a Monday. Okay? All right. Enjoy your Thanksgiving break. After learning, go ahead and get your notebooks out, your pens, pencils, books, calculators, and everything else. After learning yesterday how to write polar equations or equations in polar form, you can probably guess what we're going to do today. If you guessed graph them, then you guessed correctly. We're going to learn today how to graph polar equations or equations that are in polar form. Now, we are also going to cover an additional easy topic today called vectors. And so that's also a second topic we'll look at, so be ready for that. And understand it's something brand new. I think you'll find interesting and mentally and academically stimulating. It'll make you think. And we'll cover that topic also today. Go ahead and copy in your notes. Let me grab a drink of water here. Graphing polar equations. Lesson 7.4, the date today is the 19th. The date is the 19th. And let's go ahead and get started. Here we go. I'm going to give you some steps, so you might want to pause the video and write these down. Matthew and Chase, I'll start with you first because you guys have graphing calculators. In order to graph polar equations, the first thing you do is you push your mode button. Your mode button is right here. When you push the mode button, you're going to then scroll down to the fourth line. So 1, 2, 3, 4. When you get down to the fourth line, I think if you look over about the third option, it says POL. So you want to scroll down and then scroll over and highlight POL. Once you've highlighted this, hit second mode or second quit, and that will take you out of mode. But what you just did by highlighting polar is you put your graphing calculator in polar mode. Now the next step is you then would push Y equals button. Here's Y equals. Now when you push the Y equals button, excuse me for yawning, a little late at night, when you push the Y equals button, up's going to pop because you're in polar mode. Up is going to pop R subscript 1 equals R subscript 2, R subscript 3, etc. That's what's going to pop up. And that's when you enter your equation right here, or here, or here, or wherever you want to. Okay, and we'll practice this later, trust me, okay? Now when you enter the equation, you're going to use this button right here. You're going to use the X, T theta N button for theta, and that button is right here. See it on your calculator X, T, theta, N. Okay? And that's the button you're going to use when you get to theta in your equation. Again, this should sound a little confusing. That's okay. When we start graphing these, I will explain what I mean. And then you're going to fill out a table of values with about 13 values on it, going from 0 to 360. Now, Caleb and Corey, you don't have graphing calculators, so you're not going to worry a whole lot about steps 1 and 2. And by the way, don't go tell your parents they got to spend $130 on a graphing calculator. That's not necessary. They're nice to have, and they're definitely going to save you a lot of time on these problems, but you don't have to have one, okay? So you guys will skip steps 1 and 2, and you're going to take the equation and fill out a table of values using 13 values going from 0 to 360. And then you graph the equation not on a regular XY coordinate plane, but on a polar coordinate plane, which makes sense because you're graphing a polar equation. Okay, so those are the basic steps. Let's go ahead and jump into this and see how we do. We're going to graph 1, 2, 3, and then we'll get into vectors. Okay. So here we go. Let's graph this polar equation. Now, Chase and Matthew, go ahead and go to mode and put your calculator in polar form. After you've done that, go ahead and hit the Y equals button, and when you do, up's going to pop. Ups. I don't know why I keep saying ups. Up is going to pop. I guess I'm doing a contraction for up is going to pop, so up's going to pop. But anyways, hold on one second. I'm clearing out my calculator now. Up is going to pop. R subscript 1 equals. And so you're just going to put 3. Hit the number 3. There you go. Wasn't that easy? That was so easy. Now, Caleb and Corey, just sit tight and hold on, okay? Now, Chase and Matthew, if you'll go to your window button, and your window button is right here. Right here. There's your window button right there. If you'll go to your window button, and when you push window, then you're going to see theta minimum and theta maximum. Well, obviously make your theta minimum what? I already told you, 0. And make your theta maximum what? 360. There we go. Pretty simple. And then you're going to scroll down a couple more steps and you're going to see X minimum and X maximum. Don't worry about really putting any numbers for those because we really don't know what our X, min, and max are going to be until we've done a little bit of looking at the table of values. Okay, so hopefully you're with me. Now, sorry for stuttering there. So you should have gone to your window button, Matthew and Chase, and made your theta minimum 0 and your theta maximum 360. Now I want you to do something else. Now I want you to hit the second button, the yellow button, and then window. So hit second and then window, and when you do that, up should pop a table setup screen. If it doesn't say table setup, then you've made a mistake. If it does, then you're good. Okay? And now what you want to do is you want to go down to the very first line, says table start. And you want your table of values to start at 0. So go ahead and put a 0. And then if you'll go down to the next line, it says table equals, or TBL equals. You're going to put 30 for that. And what that means is you want your table to go in increments of 30, which we do. I'll explain that in a second. Okay? So hit second window, up pops the table setup window. For table start, you type 180, and the next line says TBL. Go ahead and type in 30. Let me get a drink of water here. Okay, and now that you've done that, we're ready for our table of values. So now I'm going to pick up with math with Corey and with Caleb. Sorry, Caleb. All right, so here we go. First of all, our table of values is going to look like this. All right, and then the values that we're going to put in are going to go from 0 to 360, and we're going to count by 30s. And I'm not going to try to be neat. I'm going to just be pretty sloppy and go fast. Remember, we're only doing 3 of these, and I only gave you 4 of these for your homework, okay? So it's reasonable, just 4, okay? There we go. Now, Matthew and Chase, if you'll hit second graph, which is this button right here, hit second and then graph, up will pop your table, okay? And when you see that, you're going to see you're really getting nothing out for theta. It's just r equals 3, okay? And the reason is, sorry, the reason is all that we have is r equals 3, and I knew that was going to happen. And so really we have no theta in this polar equation, and we have no sine or cosine or anything else. And so what it means is r is 3. It just simply means that we go out to ring number 3, and we just draw a circle right there, and that's it. Well, Mr. Earhart, what about the table of values you were talking about? Well, students, we're normally going to use one, okay? But in this problem here, there we go, it's supposed to be a circle. In this problem here, when it's just r equals 3, all that means is no matter what angle you're at, you're going to go out to 3 and just draw a circle. Okay, and that's all you're going to do. Okay, so there really is no table of values to fill out on this one, but you still need to be ready to. Okay, so for Chase and for Matthew, your calculator is now set up. You're in polar form. Your window is set up from 0 to 360, and your table is set up to start at 0 and go in increments of 30. So you're all set, okay? And so we really didn't need a table of values on this one because we could just see r equals 3, okay? All right, so there we go. We graphed a polar equation. Now let's get into some more difficult ones, okay? All right, let's try this one here. Let me get another drink of water here real quick. Okay, here we go. Now, let's graph this polar equation. Now, first of all, for Corey and Caleb, go ahead and draw your, in fact, I'm going to go back a page and I'm going to save me some time. I know it's not super neat, however, it'll still save me time. There we go. Now, and actually not just Corey and Caleb, but all you guys, go ahead and draw your table of values real quick, going from 0 to 360. You do need to do that, whether it's a pain or not. You need to do that, okay? All right, now after you've done that, remember, those that have a graphing calculator, go ahead and go to your y equals button and push that button, and when you push that button, up on your screen will pop the r subscript 1 equals, and you're going to type in 5 sine, now hold it, theta. How do you get a theta? Well, remember this button right here? This is your theta button right here. That's your theta button right there. Push that and theta will pop up. Okay? Alright, so you type this into your calculator, and now here's what I want you to do. Hold on just one second, Caleb and Corey, Chase and Matthew. Go ahead and hit, I'm going to go ahead and enter this into my equation. Y equals, hold on one second. Okay, I'm going to go ahead and go to my table. I'm going to hit second graph or second table, and what you're going to see are different values popping up over here. So in a second, that's going to tell us where to put our window when we hit graph. But for right now, 0 should give you out 0, and 30 should give you out 2.5. Now, for Corey and Caleb, here's what you got to do, guys. It's a little longer for you guys, but it's okay. You're going to put 0 in for theta. So you're going to type in 5 sine 0 equals, you'll get 0. Then type in 5 sine of 30 equals, and you'll get 2.5. Then hit 5 sine of 60, and you'll get 4.33. All right? And we're going to continue this all the way down through here. Okay? So next would be a 5. That's not a 0.5, that's 5. And then 4.3. Of course, I'm rounding there. 2.5. 0, negative 2.5, negative 4.3, negative 5, negative 4.3, negative 2.5. Remember, just one more of these after this and we'll be done, okay? All right, there we go. Now, students, watch this. Look at your y values. The highest number I see positive y's is 5, and the lowest I see is negative 5. So real quick, Chase, Matthew, push your window button. Push your window button. And then scroll down to where it says X min and X max. Don't put 5 and negative 5. That's cutting it too close. Go a little bit past. Notice how your highest number over here is 5 and your lowest number over here is negative 5. So you want your range to go from negative 5 to 5. So I would put negative 6 for your minimum, and I would put positive 6 for your maximum. Okay? Now for Corey and Caleb, don't worry about that. There's nothing to do. You have no window in your calculator to worry about, so you just go ahead and fill in your table of values. Now we're going to plot these points. It's not going to be as easy as you think, so please pay attention, okay? Really pay attention, please, okay? All right, now here we go. Watch carefully what I do. Okay, 0, 0. That means I go to the 0 degrees, and I go to 0 right here. Very good. Now, 30 is 2.5, so I go to the 30 line, and I go on the 30. I go 1, 2.5, so there's 32.5. Then 64.3, so I go to 60, and it's 1, 2, 3, 4, 4.3 right here. And then 90 is to 5 right here. And 120 is 4.3. So 120 is 1, 2, 3, 4.3. 150 would be 2.5. 1, 2.5. 180 would be 0. So back to here again. Okay? Now, here's where it gets tricky. Notice it's 210, so here's my 210 ray right here. Do you see that, guys? But it's not a positive 2.5, it's a negative 2.5. So I rotate to 210 degrees like I'm supposed to. There's 210 degrees, but then it's a negative 2.5. So then instead of staying right here on 210, that negative 2.5 means I reverse my direction and I go back this direction here to 30 right here. So 210, I reverse my direction to this and I go to 2.5 right there. So the negative 2.5 right here, this negative 2.5 means I rotated 210 degrees, and then because it's negative I go the opposite direction, so I end up hitting this exact same point right there. Same thing with 240. I rotate to 240, then it's negative 4.3. So 240, if I start at 240 right here and then go backwards, I'm at 60 and I hit right there. The same thing will happen with 270. I rotate to 270, then notice it's a negative 5. So instead of being on my 270 ray, I go the opposite direction. I go back up here, and that's 5. If you continue, you're going to see all these points are just going to be repeated points. So your graph just looks like this. I'm not the best drawer in the world, but you get the point. So a circle that's up in the air. There you go. I hope you're getting this. It's not super easy. It's really not. You've got to think this through, especially plotting the points right here. Okay, one more, okay? One more and we're finished. Now, for you men that are not using a graphing calculator, remember, you can go ahead and start filling in your table of values, okay? Now be careful, but just make sure you do it correctly. Those that do have a graphing calculator, when you type this in, when you hit your y equals button and then type this in, it's 2 cosecant theta. Now think about that. Let's do a little work. And you men that don't have a graphing calculator, you still got to do some work to this thing. I mean, look, cosecant, we don't have cosecant on our calculator, so 2 cosecant theta, that's 2, and then what can I put for cosecant? 1 over sine theta. I mean, that's what cosecant equals, is 1 over sine. And now I have 2 times 1 over sine, or 2 over 1 times 1 over sine. 2 times 1 is 2, and 1 times sine is sine. So really, 2 cosecant theta is the same thing as 2 over sine theta. So if you're going to type it into your grapher on the y equals part, then go ahead, you would type it in like this. You would hit 2 and then divided by and then sine, and then hit the button that makes theta pop up like that. And that's how you would type that into your graphing calculator. Now for those that do not have a graphing calculator, you're just going to enter these values in and get values out. Then use this right here. Type in 2 divided by sine of 0 and get something out. Type in 2 divided by sine of 30 and get something out. Okay? Now I'm going to very quickly go to my graphing calculator. Remember, we're just doing, this is our last one. So we're almost finished, and I have my table of values here, and let's see what's going on here. Okay, hopefully some of you are already working on your table of values. 0 is actually going to give you out error, so it's not going to work. All right. So I'm going to put not defined. And then for 30, I'm going to put a 4. And then 2.3. and then 2, 2.3. I'll try to go fast here. 4, not defined, negative 4, negative 2.3, negative 2, negative 2.3, negative 4, and not defined. All right, now here we go. Watch how fast we do this. Okay, this ordered pair does not exist. 34. So let's make this pretty big real quick here. And here we go. 34. So 30 and then 1, 2, 3, 4. So there we go. And then 62.3. So here's 61, 2, 2.3, and then 92. So here's the 90 line, then 1, 2. And then 120, 2.3. So 1, 2, 2.3. And then 150 is 4. So here's 150, 1, 2, 3, 4. And then 180 is not defined, and then 210 is negative 4, so I go to the 210 ray, but because it's a negative 4, then I go back the opposite direction here. Oh, it hits right here, there's 4. And then 240 is negative 2.3. Well, that's going to hit that same point right there. 270, negative 2. Here's the 270 ray, but I'm going to go negative 2, so I go the other direction. It's right there. And then so on and so forth. This point will be repeated, and this point will be repeated right here. And so what you see is you have a line. That's it. You have a straight line, okay? And that's the graph of this polar equation. Now, the only really advantage to having a graphing calculator on these, as Matthew and Chase will tell you guys, is they just simply type the equation in and hit a button, and the entire table appears on the screen for them. Whereas with you guys, you're going to have to type each x value in and get out a y value. By the way, I probably shouldn't have put x and y. I probably should have put theta, because that's what you're putting numbers in for, theta and r. Okay, but either way, that's how you graph those. Now that's not too bad, and I've given you 4 of those in your homework. All right, so you'll be fine. Excuse me, grabbing a quick drink of water. And now we're going to go ahead and take a look at a new topic. So, graphing polar equations. I hope you got it. I hope I've explained it well. Practice, practice, practice. You'll have 4 of these in your homework. And please really, really check your homework well, okay? All right. Now, I want to take a quick second and introduce you to the concept of vectors, okay? The concept of vectors. Now, I will tell you when I need you to write something down. I do want you to write this down. Your heading is vectors, and it's lesson 7.5, and even though it feels like an eternity, it's still the 19th, November 19th, okay? So please copy that in your notes. We describe time, length, and mass using units like seconds, feet, and kilograms. I mean, time can be in seconds, length can be in feet, and mass can be in kilograms. However, for quantities like displacement, velocity, or force, we need to describe a magnitude and a direction. For example, if I'm exerting force on an object, I not only have to know how much force, I have to know what direction I'm pushing the force, okay? And with time and length and mass up here, you really don't necessarily need a direction for those. But for force, velocity, and displacement, you're going to need a magnitude, okay, and a direction that the magnitude is taking place. That's where a vector comes in. Together, magnitude and direction together describe what a vector is. So a vector is a mathematical principle that we can use that puts together the magnitude and direction of a given force. Okay? Now, I'd like you to go ahead and copy this in your notes if you would. All right? go ahead and copy a coordinate plane. I want you to put a point right here at -1, 2, and then I want you to draw a line that ends at 4, 4. Now, even though it has an arrow, that arrow does not mean that the line continues on and on. It's not what it means. Okay, this line is what we call a vector. I'm going to talk about that in a second. Okay, but this arrow is just showing the direction of the vector. Remember, a vector has direction and magnitude. Direction and magnitude. Okay? Now, because we have a vector moving in a certain direction, there are a couple terms you need to know. These are really important. This starting point where the dot is, you need to know that's called your initial point. Your initial point, because that's where the vector is starting. And this arrow, remember, this arrow does not mean that it continues on and on. It stops right here. That's where it stops, okay? But we put an arrow so we know that the vector was running this direction and not this direction, okay? But the vector still stopped right here. And so we're going to call that R. Please make note of this. You need to know this, guys. Our terminal point. So the starting point is called your initial point, and your ending point is called your terminal point. And this right here, men, is called a vector. This is what a vector looks like right there. Okay? It's just a directed line is all that it is. A directed line. All right? Let me grab a quick drink of water here. Now, with that in mind, let's continue on. Actually, let's not continue on. Let's go over this one more time. So here's a vector. It's a directed line or a directed ray. It has an initial point, a starting point, an ending point, a terminal point. And by the way, notice the direction of the vector. What about the magnitude? The magnitude would just be the length of this vector. So please do get used to that and understand that. When I say what's the magnitude of a vector, that means the length of the vector. Okay? All right, let's continue on. Now this is very important. Two vectors are equivalent if they have the same magnitude or length, and they also have to go the same direction. They have to run the same direction. Okay? For example, let me draw some stuff here for you. I would definitely write this sentence in your notes. That's really, really important. And here's what I mean. If I have a vector that looks like that, and one that looks like that. Now, it doesn't look like they're totally going in the same direction, but they really are. There we go. And let's say they both had a length of 5. Then we would say those two vectors are equivalent. Look, as long as they're going in the same direction and they have the same length, then they're equivalent. And by the way, they don't have to be side by side. This vector could be down here. As long as it's going the same direction and as long as it has the same length as the other vector, then the two vectors are equivalent. So by the way, if we were to take this this vector and do this number. Now the lines still have the same slope, but notice they're going two different directions. This one's going this way and this one's going this way. So these two vectors now would not be equivalent. So let me sum it up like this. I'm going to ask you in your homework today to tell me whether or not two vectors are equivalent. Here's what you need to check. Are you ready? You need to make sure the lengths of the two vectors are the same. You need to make sure they're running the same direction. That means they're pointing the same direction. There's 3 things you got to check. Pointing in the same direction. And then lastly, they must have the same slope. And you know how to find the slope of a line, hopefully by now. And so they must have the same slope, they must be pointing in the same direction, and they must have the same length. Okay, so with that in mind, let me give you some closure. Hopefully you've listened really well today. We're going to take a look at this problem, and then there's your homework right there. So we're just about done, okay? So let's take a second and let's look at this problem. Are these vectors right here? Now these aren't vectors, these are just ordered pairs, okay? Are these vectors right here equivalent? Are they equivalent? Now, as we check to see if these two vectors are equivalent, and by the way, again, like I said, these are not the vectors up here, these are ordered pairs. This is a vector symbol. When you see two letters and a line over with a little hook like that, that means vector CG. Now, of course, C is this point and G is this point. Let me show you what that means. First of all, one of the first things you always want to do, in my opinion, students, when you're asked the question, are these two vectors equivalent? One of the things you'll want to do is to very quickly, and I do mean very quickly, just get a picture of what they look like. I mean, come on. What if you graph one vector and it looks like this? And what if you graph the other one and it looks like this? I mean, you know then they're not equivalent. They're not going the same direction. They're definitely not the same length. Now, sometimes it's too close to tell, but I always try to very quickly graph the vector. So, this is vector CG. So, C is negative 2, 5, and G is negative 4, 4. Do you see how I got that? Here's C, here's G. Now you know what this means? What letter came first over here, C or G? Well, C did. So this is your initial point, and this is your terminal point. So initial point, negative 2, 5. Terminal point, negative 4, 4. So about right here, kind of a small vector. This is my negative 2, 5, my initial point, and it goes this way. And when it hits this point, I put an arrow right there. There we go. Now, vector FP. Now, vector FP, of course, F is going to be 2, 1, and P, that should be a P right here. I apologize. Let's make that black, and let's make that a P. Okay, there we go. Sorry about that. And so then P, vector FP, P is 0, 0. Okay, so this would be your initial point, and this would be your terminal point because F came first. All right, so 2, 1 over 2 up 1, and then 0, 0. Oh, this is too close to tell, isn't it? I mean, it looks like they might be running the same direction. It looks like they might be the same length. Do you see what I'm saying? It looks like they might be equivalent. So we've graphed them, we've looked at them. Now we got to really make sure. Okay, so I'm going to go ahead and get rid of this stuff real quick. Put it all down here in the trash. Because we took a look at them and it looks like they really could be equivalent. So now we've got to check the length of each one, make sure they're the same, and check the slope of each one and make sure they have the same slope. Alright, we already know they're running the same direction, remember? We should check the direction too. But we really just did that because we saw one was running like this and we saw the other one was running like this. So we know they're pointing pretty much the same way. So I really have already checked the direction. So I'm going to put check right there. But now I've got to make sure they have the same slope. So let's first of all check the slope of these. Do you remember how to check the slope? Y minus y over x minus x. So I'm going to take these two ordered pairs, y minus y, 5 minus 4. Remember, this is my x, this is my y, this is my x, this is my y. So y minus y, 5 minus 4, x minus x. Negative 2 minus a negative 4. Okay, well, 5 minus 4 is 1, and negative 2 minus the negative 4, if you're not good with your sign numbers, use your calculator. Negative 2 minus the negative 4 would be a positive 2. So there's the slope. M means slope. So there's the slope of my first vector. Now let's find the slope of this vector. Here's my x, here's my y, here's my x, here's my y. Okay, y minus y, so 1 minus 0. X minus x, 2 minus 0. and 1 minus 0 is 1, and 2 minus 0 is 2. So far so good. So I know they're facing the same direction. These two vectors are. I saw that when I graphed them. And I know they have the same slope. I just did that. Now let's see if they have the same length. Now this might be something you've forgotten from Algebra 2. There's a formula called the distance formula that helps you find the distance between 2 points. And it's the square root of x minus x squared plus y minus y squared. Okay, so we're going to use this formula to find the distance between these 2 points, because when you find the distance between these 2 points right here, between these 2 points, then you're finding the length of the vector. And when you find the distance between these 2 points, then you're finding the length of the vector. So let's find the length of vector CG. So first of all, it looks like to me I have square root of x minus x. So here's my x, negative 2 minus a negative 4 squared. And then the formula says put a plus sign, and then the formula says y minus y squared. Well, let's see. Here's my y and here's my y. 5 minus 4 squared. So 5 minus 4. Now, it shouldn't be too hard. Negative 2 minus negative 4 is 2, and 2 squared is 4. 5 minus 4 is 1, and 1 squared is 1. So 4 plus 1. So square root of 5. So there's the length of this vector, vector CG. Now I'm going to find the length of vector FP. And if they're the same, then I definitely have equivalent vectors. If they're not the same, then I don't. So x minus x, 2 minus 0, plus y minus y, 1 minus 0, squared. 2 minus 0 would be 2, 2 squared is 4, 1 minus 0 is 1, 1 squared is 1, and 4 plus 1 is 5. So everything's checked out. Were these two vectors running the same direction? Yes. Did they have the same slope? Yes. Did they have the same length? Yes. So are these vectors equivalent? Yes. Can I say something to you, men? If any of these three things, if just any one of these three things had failed, then we would not have equivalent vectors. If they weren't running the same direction, or if they didn't have the same slope, or if the length was not the same, if any of those wasn't accurate, then you would not have equivalent vectors. Okay? I hope this has been a help to you. Your homework assignment is page 644, 63 through 69 odd. That's 4 graphing problems. Do the best you can. Use the help video to help you, and look in the back of the book, compare your answers. And then page 652, numbers 1 through 11 odd. That's practicing the vector types of problems that we just finished with. Okay? I hope you guys have a good rest of the day, and I will talk to you tomorrow.